Over this next series of lectures, we'll be discussing process management in Linux. A process is basically a program that has been copied or loaded into memory by the kernel and is either running or waiting for instructions. As you can see, we take the program off the disk, put it into memory, and the CPU executes the code that's in there. There are a bunch of different commands that we can use to manage processes. And if you've ever used Task Manager in a Windows environment, then this is exactly the same thing. We'll be looking at PS, PS3, top, main tools for actually observing what's going on the system as far as processes go. And then we'll be looking at jobs, and I'll explain to you the difference between a job and a process. And then finally we'll look at the kill command, which allows us to stop or restart processes if necessary. Let's go and take a look. The first command we'll look at is the PS command. The PS command provides you with a snapshot of what processes are running on your system. If I just type PS here with nothing else, I will see the processes associated with this instance of bash that's running right now. And that's the only thing I see. These are processes owned by this process bash. I can see the ID of the bash process, which is in here, which is, by the way, owned by another process. We'll show you that in a second. And then I can see that I ran the PS command and it received the process ID. Now that's interesting because the PS command ran and then ended. Because it ran, it was given a process ID by the system. Now PS has a few different versions, gone through a couple of changes. If I type man PS here, you can actually see that you have traditional Unix options, which typically begin with a dash. BSD PS version has no dashes. And then there's the GNU version of PS that actually uses multiple dashes. I know, very bizarre. Honestly, it really is not a big deal. You'll get used to one or two of the formats and use that. There is a difference between them. So notice, if I type PS-A here, I get the process ID of the PS command. If I type PS space, no dash, and press enter, I get a very different output. I still get the information about this PS command, right? So this PS command ran and received this process ID, and then it died, it ended, it did its job. And then I ran PS again, and it received the process ID, but I'm getting a lot more information with that. Now that's not always a good thing, but it's just something you need to know about. So let me get out of here. I'll type PS-L, and we can see not only do we receive a process ID, but we can also see who our parent of the process is. If I type PS-E and pipe it through less, you can see that the first PID, the parent of all of the child processes, is the init process, and we've looked at that before. So everything on the system has a parent and the child of that parent. And what you see right here with this is that my bash environment started up and received a PID of 2233. I ran PS. It received a PID of 2281, and its parent was 2233. Most of the time, what you're looking for is this right here. You're looking for the PID of a particular process because you want to manipulate it in some way. Start it, stop it, restart it, something along that line. So you can use that information. Now I want to show you that if you go into a Windows environment, this is a Windows PowerShell environment, and I ran the get-process, which is kind of like PS in Linux, and you can see I have process IDs here also. So this is not unusual to an operating system. Every process on the Windows machine receives an ID, just like Linux does. All right, if I type PS dash or just PSAUX and press enter, I see all the processes on the machine and who owns those processes. Now it's interesting, you see many of them are owned by root because when the system starts up, it uses the root account to start those processes. But there are other processes like the email server is up, the Apache server, it's owned by the Apache user. Remember we looked at user accounts. We saw that there were these system accounts where here you go, this is where they're being used. And then I can see all the processes owned by me, the student, as I'm logged in. One thing I want to show you is I'll type PS-L again. And you can see the processes. If I start another process like sequence, and this is just basically going to create a random bunch of numbers in a file, but I'm not going to save it to a file. I'm going to tell it to dump to dev null, put it in the background. If I type ps-l here again, I can see that that process is running. And if you look over here, you see all these zeros. That's showing you CPU usage time. You can see sequence is actually using time. So the sequence command is actually doing something. Now, what's interesting, type that again, ps-l, the sequence command is the child of bash. So in Linux and Unix world, when typically you kill the parent, the child goes away too. And that may not be something you want done. So if I close this terminal, that PID, parent 2233, dies, goes away, ends, and it will take the sequence command with it. Let's test that already. I'll get in here, close that, open it up again, clean this out a little bit. I'll do a ps-l here. We can see it's not here. Well, that makes sense because I killed that shell, but is it running in the background is what I want to know. Did I kill that command? And if I type ps-aux and grep for sequence, you can see that there's nothing on the system running with sequence. So that means that process died when the terminal closed, and that's not unusual for that to happen. If you don't want that to happen, what you have to do is issue the NoHub, which stands for no hang up. That's what it stands for. So the NoHub command, and then run sequence. Big number, or lots of numbers, I should say, not a big number. Dev null. And I'll put it in the background. Okay, it's giving me a little thing about it's not taking any more input, and it's going to redirect the output. Once again, ps-l here. There it is. There's the PID associated with it, 2325. I'll exit out of here. Open up the terminal. Come back in here. I'm going to do a ps-aux, and this time I'm going to grep for sequence. And last time we did this, it died, right, when we closed it. Well, we closed it again, and look what happened. Because I issued the NoHub, even though the terminal went away, the sequence command is still running. So if you want something to keep running in the background, if you close a terminal, you always have to use the NoHub command. Or there's actually a great utility called screen that'll allow you to use multiple screens. But that's an introduction to the ps command. Next, we'll look at top in its various forms. And the top command gives you real-time information about your system.